A fully equipped 10-story apartment building was completed in just 28 hours and 45 minutes. Not just the frame or basic structure, the entire finished building, including interior walls, windows, balconies, plumbing, electrical systems, everything ready before the next sunset. And that was only the beginning. The same approach later produced a 57-story skyscraper in 19 days. Then a 26-story residential tower rose in just over 5 days. By comparison, traditional methods typically take around 16 months for a building of similar height. So either those standard timelines are seriously outdated, or something profound has shifted in how we construct buildings. What makes this even more remarkable is that all of it emerged from China, and the person who pioneered this system wasn't a trained architect or structural engineer. He had zero background in construction. His previous success came from selling air conditioning units. His entry into building design actually began after one of the most devastating earthquakes in recent history. If you like stories about unexpected innovations reshaping entire industries, hit like and subscribe. We focus on exactly these kinds of developments, and you won't want to miss what's ahead on this channel. To understand how a former air conditioning entrepreneur ended up constructing skyscrapers at speeds once considered impossible, we need to go back to 2008, the man who asked the right question. Zhang Yue built his reputation and fortune through Broad Group, a major manufacturer of central air conditioning systems across China. It was a solid industrial success story. He wasn't seeking public attention or trying to revolutionize anything. He was simply running an efficient company that excelled at one specialized area. Then the 8.0 magnitude Sichuan earthquake struck in 2008. Nearly 70,000 people lost their lives. Tens of thousands of concrete buildings collapsed. Schools crumbled during the day with children inside. Hospitals and apartment blocks that had stood for years were reduced to rubble in moments. Zhang Yue couldn't shake one clear realization from the devastation. Concrete is heavy and inflexible. When the earth moves violently, it doesn't bend, it breaks. And when it breaks, everything inside comes down with it. The buildings didn't fail primarily because of poor maintenance or age. They failed because the material itself wasn't suited to absorb that level of force. Yet the world continued relying on it, pouring it and stacking it floor after floor, year after year, as if no superior alternative existed. He posed one direct question: why are we still building like this? That question quickly moved from thought to action. Zhang redirected his entire operation. Engineering teams, factory capabilities, supply networks, everything he had developed for air conditioning toward a new mission. He wanted a construction system that could be assembled rapidly, withstand extreme conditions, and eliminate the need for wet concrete on any job site. He approached the challenge from first principles rather than industry traditions. What does a building fundamentally need? Stability, resilience under stress, livability, durability. Everything else was open to reinvention. He brought together engineers, materials specialists, and manufacturing experts from fields already skilled at producing complex items with precision and speed in controlled factory settings. It was aerospace-level thinking applied to everyday architecture and industrial manufacturing logic applied to housing. Years of development, failed prototypes, redesigned connections, and refined processes followed before the first viable system emerged. But once it worked, it transformed the possibilities. Buildings that arrive flat-packed. Every component of a Broad Group building is manufactured inside a massive factory under controlled conditions. Walls, floors, balconies, wiring, plumbing, ventilation, all of it is completed before anything leaves for the site. The factory spans roughly 230,000 square meters, the equivalent of dozens of football fields under one roof. Individual sections are built as modules similar in size to large shipping containers. Walls fold flat for shipping. Balconies tuck inward. Windows are pre-installed. Wiring and plumbing are already in place and tested. By the time a module exits the factory, It's essentially a finished room ready to be positioned and connected. Trucks deliver the modules to the site. Cranes lift them precisely into place. Steel bolts secure each one to its neighbors. The building assembles much like large-scale flat-pack furniture, except the furniture is multiple stories tall and designed for families to live in long-term. No concrete is mixed on site. No waiting for slabs to cure. No weather-related delays halting progress. No juggling multiple subcontractors with conflicting schedules. The site becomes an assembly area rather than a traditional construction zone. Traditional building is like preparing an elaborate meal from scratch in an open field with unpredictable conditions and many hands involved. Broad Group's method is more like a professional kitchen where every element is prepped, tested, and finished in advance before final service. The professional approach consistently wins on speed, quality, and reliability. Because everything happens in the factory, quality checks are thorough. Modules are inspected before shipping. Tolerances stay tight. When they arrive on site, they fit as designed. To demonstrate the system's potential, Broad Group recorded a complete build. With the foundation prepared, they raised a full 10-story residential building, from first module lift to final connections, in 28 hours and 45 minutes. The time-lapse footage spread rapidly online. Millions watched. Engineers, architects, and developers reacted with a mix of disbelief and excitement. Some called it revolutionary. Others dismissed it as a staged demonstration that wouldn't hold up in real conditions. Broad Group responded not with words but with bigger projects. 57 floors in 19 days. The next challenge wasn't 10 stories. It was 57. They built Mini Sky City, a 204-meter-tall mixed-use skyscraper containing 800 apartments, offices for 4,000 people, and ground-floor retail. The entire structure went up in 19 days. Teams averaged 3 full floors per day. Modules arrived in a steady flow. Cranes operated continuously. Crews locked sections together and moved upward without pause. Over 90% of the building arrived pre-finished from the factory. A conventional skyscraper of that height normally takes about 2 years. This one was completed in 19 days while eliminating thousands of concrete truck deliveries. The achievement shifted industry perceptions. Modular construction at height moved from interesting concept to proven reality. Developers began rethinking timelines. Planners reconsidered project schedules. Investors took notice. A few years later, a 26-story residential tower called Jindo rose in just over 5 days with only about 100 workers on site. That's a small enough crew to fit on one bus. Yet they completed a building taller than many urban apartment blocks faster than most people finish a standard work week. No large contractor armies. No months of coordination. Just efficient module delivery and assembly. At that stage, the debate changed. The question was no longer whether the system worked. Buildings were standing and occupied. The real question became, if it goes up this fast, is it actually safe and durable? Engineered to endure for centuries. Independent testing by the China Academy of Building Research confirmed that Broad Group structures are rated to withstand magnitude 9 earthquakes, among the most powerful ever recorded. Their expected lifespan reaches around 1,000 years. Buildings completed in under 30 hours are designed to outlast typical modern concrete structures by a factor of 10. Most conventional buildings target 50 to 100 years. The steel modules are significantly lighter yet far stronger under stress than concrete panels. During seismic events, the structure flexes and absorbs energy where concrete would crack and fail. Because everything is bolted rather than permanently poured, the building can eventually be disassembled and recycled at end of life. Construction waste drops by over 90% compared to traditional methods. No massive concrete debris, no excess rebar, just reusable steel components. The speed grabs attention. The safety ratings interest engineers. But the environmental advantages may be the most significant long-term benefit. Traditional construction is one of the biggest sources of waste and emissions globally. a system that slashes waste, reduces material transport, and creates longer-lasting structures, represents a fundamentally better approach. Broad Group is only part of the story. While they perfected modular assembly, another Shanghai company approached the challenge from a different angle, one that feels almost futuristic. The company printing buildings while you sleep. Winson doesn't stack pre-made modules, they print structures. Large robotic nozzles move along programmed paths, depositing layers of a special mixture made largely from recycled construction waste and fast-setting materials. Wall by wall, layer by layer, the printer creates complete structurally sound houses. In a single 24-hour period, Winson has produced 10 fully finished houses ready for occupancy. Material usage drops 30 to 60% compared to conventional methods. Labor requirements fall sharply because the process follows digital files. Designs can be customized easily without retooling. Complex curves and organic shapes cost the same as straight walls. This technology opens new possibilities for affordable housing, disaster relief shelters that can be printed quickly in needed configurations, and community buildings in remote areas where traditional construction is impractical. Winson and Broad Group use different technical approaches, but one stacks, one prints. But both move construction from unpredictable outdoor handwork into controlled, repeatable, automated systems that minimize waste and maximize precision. Why the old methods still dominate? The global housing shortage exceeds 100 million units and continues growing. Construction costs are rising everywhere. Skilled labor is aging and shrinking in many countries. Cities are expanding faster than housing supply. The pressure is intense and global. The technology to address much of this already exists and has proven itself in multiple cities. The modular construction market reached about $95 billion in 2025 and is projected to exceed $175 billion by 2034. Asia-Pacific accounts for a large and growing share. Governments, including China's, are directing significant funding toward faster, more efficient methods. Singapore has mandated modular approaches for public housing. Other nations are investing heavily as well, yet most of the world still builds using century-old techniques. Building codes, supply chains, developer habits, permitting processes, and labor structures were all designed around traditional methods. Changing them involves time, testing, and political will. Unions worry about job impacts. Developers hesitate to take risks mid-project. The gap between what's technically possible and what current systems allow is the real challenge. But that gap is narrowing. The economics are compelling. The housing needs are urgent, and the direction of progress is clear. A former air conditioning executive watched buildings collapse in an earthquake and questioned the status quo. He built a factory, redesigned the entire process, and raised a 10-story apartment in less than a day and a half. Another team aimed giant printers at recycled materials and produced multiple houses in 24 hours. The new approaches are faster, stronger, safer, more affordable, and far better for the environment. The only remaining question is how long the traditional system can hold on while better solutions stand ready. If this kind of story about innovation-changing industries appeals to you, hit like and subscribe. Turn on notifications so you catch the next one. Here's a question for the comments. If a building assembled in under 29 hours can last 1,000 years, what does that suggest about the concrete structures around us today? Share your thoughts below. I read every comment.